station is an unbelievable research facility that we need to expose to a terrestrial group of research community. And by that, pharmaceutical companies, they do a lot of research here on the ground to develop new drugs and to essentially build new drugs and look at new ways to control disease. In the case of space, it turns out bacteria become stronger in space for some reason we don't fully understand. But the pharmaceutical company, they can use this property of space where bacteria become stronger to investigate new approaches to developing drugs to control disease or vaccines to even prevent disease. So what's unique is we're trying to now take a broad group of terrestrial pharmaceutical companies, expose them to the benefits of space, and see if they can use the properties of space to gain a market advantage over companies that are not doing research in space. And if they can, then they're going to want to go fly to space because they'll have a competitive advantage over companies that are not doing basic or fundamental research in space. And when that occurs, because we've established a commercial cargo capability and a commercial crew capability, they can have essentially their own space station, again, privately provided. They can then go acquire a commercial rocket to go fly to it, cargo to it. They can develop go acquire a commercial crew transportation capability to go to their research facility in space. So we've enabled all pieces of those markets. And then what happens then is NASA no longer needs to be funding this research in low Earth orbit. There's now an established cargo capability. There's an established crew capability. There's a research pull moving forward. And then NASA can do the things beyond low Earth orbit and move crew further out into the solar system, and it frees NASA's funding up to go do those. So I envision some world where low Earth orbit is turned over to potentially maybe the National Institute of Health, the National Science Foundation, and other commercial companies, and a predominant amount of research is coming from them, where they can take advantage of all these unique properties of space that we found and discovered through our research on station. But they can now use those in a marketable way that provides revenue to them, and they provide a pull for this industry moving forward. So then space is no longer a government-only industry. Space is really now a much more robust industry composed of private sector activities as well as government activities. What we saw in the cargo world was that if NASA was the predominant provider, in other words, NASA was the predominant need, rather, for this cargo capability, we needed cargo delivered to ISS, that was enough of a market that these companies would then invest their own money to own the design of the transportation system such that they could potentially market it somewhere else to maybe a future potential user, like in the private sector, like I described a little bit earlier. So then you look at the same thing as you go forward, like maybe in the area of life support systems. Does the commercial sector see enough interest beyond NASA potentially where they would want to have the ability to have their own life support system, and possibly. And if they do, then they will share in the investment with us in developing the next generation of life support systems. So instead of the government doing that whole development on their own, we may be able to do that cooperatively with another private sector company moving forward. I think one thing to also think about is we describe how this space station that we have today maybe transforms to a private space station owned by commercial companies. We need to not think of it being this big, expansive space station we have today. That's the government station. But could you do small things? For example, when the Cygnus vehicle is done servicing or delivering cargo to station, that Cygnus vehicle is just going to burn up in the atmosphere. So we've decided on the NASA side that we would use that to investigate fire propagation. So we're going to actually set a fire inside Cygnus and see how fire actually propagates in the microgravity environment to help us with our designs in the future. That same Cygnus vehicle could stay on orbit for several weeks, and it could perform a microgravity function for someone else. It could provide some Earth observation time for somebody else. So those could be the inklings of the starting of this new commercial market. Same with Dragon. You've heard SpaceX talk about Dragon Lab, where it may be a standalone flying small laboratory, so it doesn't even need to go to station, but they could process these biological samples. They could potentially expose rodents to microgravity, look at bone loss, look at muscle wasting on a very short flight, and return those same rodents later on that Dragon, maybe 2 weeks, 3 weeks later, and return that research back. So I think what we've done is we've created a capability that can be used in a variety of ways, so it doesn't have to always be government investment in these activities. Whereas before we thought it had to be a government contract with the government funding everything. I think what we're seeing now is there's potential with a little bit of creativity that we can step back and ask contractors, are they interested in contributing to these activities because they see a future potential beyond what we've got, and they see enough of this reality there, they're willing to make significant investments. So I think as we look at exploration activities and we think about doing things around the moon, we talk about it as a proving ground region. If we put a habitation module around the moon, I don't believe we will ever service that with U.S. cargo capability. We'll just go acquire cargo capability just like we did in low Earth orbit with space stations. So I think you're going to see in future activities much more interaction and much more cooperation between the private sector and the government doing these joint activities. And we'll use SpaceX where they're appropriate. We can use CRADAs, which is another instrument to go do that. We can use cooperative agreement notices and even contracts in some places. But again, I think we need to go look at those things as we move forward. Another example of public-private partnerships, other than the Space Act agreement, would be the activity we're doing with Bigelow and the Bigelow expandable accommodation module on board space station. It'll fly later this year. Bigelow contributed a substantial amount of funding to that activity, so we did not pay for the full contract price for the expandable module. We only paid a portion, and it's based on essentially effectively deploying it. And the reason we wanted to do that is we wanted to get a chance to look at expandable technologies as a future capability for exploration. So this was an extremely cost-effective way. So Bigelow can work with us. They can potentially market that as a future station. So he gains that piece, and we gain the chance to see how well we can actually utilize an expandable technology. It gives you a large volume. You know, supposedly better from a thermal standpoint, maybe better from an acoustic standpoint, maybe better from a radiation standpoint. We'll actually get that information, measure all that on station as part of this beam experiment they'll fly next year. So that's an example of where we're looking forward to exploration, and we're using kind of not a traditional cost plus contract, but essentially it's called a completion form type of contract where it's pay for performance kind of activity, and we'll do that with Bigelow for us to gain information and for his company also to gain information about what their capabilities are and to demonstrate to others that they have a marketable capability moving forward. So again, this is another example of a private-public partnership, not in a funded Space Act, but it accomplishes the same goals as a funded Space Act.